Hello friends, I welcome you in lecture number 3 on method of separation of variables. In this lecture we will solve this partial differential equation together with this condition. Partial differential equation is del u by del x equal to 4 times del u by del y. That is, we are given partial derivatives of function u with respect to x and y. That means we are interested in the solution u, which is function of two independent variables x and y, and we are interested in that value of unknown function u which satisfies this condition. That is, when x is 0, function u is 8 times e raised to minus 3y. And now we are familiar with this method of separation of variables. First we have to decide the dependent variable and independent variables from given equation. So here derivatives of function u are given, that means u is dependent variable, and derivatives are given with respect to variables x and y, that is u is a function of two independent variables x and y. Once we decide these dependent and independent variables, then we will start with the assumption that given partial differential equation has product solution in this form. Here I have two variables x and y. So here I am writing product of two functions. One is of variable x and another is of variable y. We assume that given equation has solution in this product form. Now because this is solution of given equation, it will satisfy given equation. Therefore, we will require this del u by del x and del u by del y. So, if we differentiate partially with respect to x, we will consider y as constant, and derivative of capital X with respect to x is denoted by x dash, y as it is. And similarly, partial derivative of u with respect to y is obtained by taking x as constant and derivative of y with respect to y. Here dashes denote the derivatives with respect to respective variable. Here capital X is function of small x, therefore this means ordinary derivative of capital X with respect to x. Similarly, y dash means ordinary derivative of y with respect to variable y. And then we substitute these values in given equation, that is, in this equation ux equal to 4 times uy, ux is x dash times y, and here 4x times y dash. And from in the next step we transfer this x on this side and this y on this side. We can transfer 4 also. So we have to write systematically all these things. I have written all these things here. This is given partial differential equation. We are given one condition that we have written by giving number 2. We start with the assumption that equation 1 has solution which takes the product form. In the product we have written functions of x and y. Then we write down del u by del x from this equation 3, that is x dash y, del u by del y is x y dash. Now this 3 is a solution of given equation, therefore we can substitute these partial derivatives which we have obtained from this equation number 3. So we substitute these two values in given equation and we have x dash y equal to 4 times x y dash. Then we try to separate the functions, we try to separate the things in such a way that on one side we have terms containing capital X, on other side we have terms containing capital Y. So this is transferred on left hand side and this y we transfer on right hand side and we obtain this equality. Now this equality contains on the left hand side we have function of independent variable x, on the right hand side we have function of independent variable y. So we have two functions which are equal. Now this is possible only if these two are equal to the same constant. On one side we have some function of x, on another side we have some another function of y. So this is possible if and only if both are equal to some constant, say k. So that we have to specify here that here x and y are independent variables. Therefore this equation 4 can only be true if each side is equal to the same constant, say k. Therefore we write this is equal to k, and from this we obtain that x dash by 4x equal to k. Similarly y dash by y is equal to k. We can transfer this 4 on right hand side, so that we have x dash by x equal to 4 times k, and this is as it is, and we give this number 5 and 6. And it is clear that equation number 5 and 6 are first order ordinary differential equation, and both are separable equations. So we can easily find out their solution simply by integrating. For equation number 5, here independent variable is small x, and we can observe that here we have derivative of x in the numerator, and in the denominator we have function x. So this is going to be log of this denominator. We are using the formula that if we have some function of x in the denominator, and if in the numerator we have its derivative, then that is equal to log of function in the denominator, which is fx. So here if we integrate equation number 5 on both sides with respect to small x, integral of this side is going to be log x, and here 4k is constant. Integral of 1 with respect to small x is x, that is log x equal to 4k times x, and constant of integration is written as log of c, so that we can combine these two. Now using the property of logarithm, by transferring this on the left hand side, we obtain that logarithm of x over c is 4 into k into x, and from this we find that x by c equal to exponential of 4kx. Okay, we are using the fact that logarithmic function and exponential function are inverse functions of each other. We know that if log alpha to the base e is equal to beta, then alpha is e to the power beta. So here also we assume natural logarithm. Therefore x by c equal to e to the power 4kx. And finally we write capital X as c times exponential of 4k into x. K is a constant, and this c is arbitrary constant. Similarly, we have to integrate this with respect to y on both sides. Integral of y dash over y, again using this formula, is going to be log y, and on this side we have to integrate k with respect to y, that is ky, plus constant of integration is written as log of, say, c dash. So that I have written here. Then we transfer this on left hand side. Using the property of logarithm, we find that this can be written as log of y over c dash, and therefore y over c dash is exponential of e raised to ky, and hence capital Y is c dash times e raised to ky. And we recall that we started by assuming that required function u is the product of functions capital X and y, and we have obtained those two functions. Capital X is c times e raised to 4kx, capital Y is c dash times e raised to ky. So that we substitute in this equation, which was given number 3, and we obtain uxy equal to, this is capital X, this is capital Y, and this we can rewrite as c times c dash e raised to 4kx e raised to ky. We can assume that c into c dash is some another arbitrary constant denoted by capital A, and these two combine e raised to 4kx plus ky. We can take k common, and finally we write our solution as a times e raised to k times 4x plus y, where a is arbitrary constant. So for different values of a, we will have different solutions. Now we are asked to find out that solution satisfying given condition. Given condition is that when x equal to 0, u is 8 times e raised to minus 3y. So whatever solution we have obtained, in that solution we have to put x equal to 0 and u equal to 8 times e raised to minus 3y, and we will be able to decide the value of arbitrary constant. So next step is use that condition. Using u0y equal to 8 times e raised to minus 3y, that is, I have to put u equal to 8 times e raised to minus 3y, and I have to take x equal to 0. So I have a times e raised to ky. Now we can compare these two sides. From this it is obvious that a equal to 8 and coefficient of y is minus 3, that is k equal to minus 3. And once we obtain these values of a and k, we substitute them in this equation. So we have u equal to 8 times e raised to minus 3 times 4x plus y. That is the solution satisfying given equation as well as given condition. What is given condition? u0y equal to 8 times e raised to minus 3y. That is, when x equal to 0, we must obtain this quantity from this solution. So we can easily see that if I take x equal to 0, here I have 8 times e raised to minus 3y. So this is correct solution satisfying given condition. So this is very easy method. You just have to remember that this is applicable for homogeneous and linear partial differential equation, and we have to first start with the assumption that solution is in the product form. For that we have to decide what are the independent and dependent variables, and number of terms in the product will be equal to number of independent variables in the given equation. And then after doing all these things, we will obtain ordinary differential equations. Here we obtain two ordinary differential equations because we have two independent variables. If we have three independent variables, we have to solve three ordinary differential equations, and after solving these ordinary differential equations, we are able to decide values of functions x and y that we substitute in our assumption, which was u equal to x times y. And finally we use initial condition to determine the particular solution satisfying given condition. So this is all about this session. I hope you like it. Thanks for